Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023, Paper 1 Variant Theory. In today's lesson, our main focus will be on mechanics questions from this paper. We will discuss these questions in detail as always we do, so you can improve your conceptual understanding of this topic and also you can have better understanding of these questions. Let's study together, let's improve together. In today's lesson, we are talking about June 2023, Paper 1 Variant Theory. Total time for this exam is 1 hour and 15 minutes and there are 40 questions on this paper. You need to answer all questions on this paper. And total mark for this paper is 40. On second page of exam paper, some important data and also some important formulae are given. In the exam, if you need value of any constants or if you want to double check any formulae, you can come to the second page of your exam paper. Question 1 says, what must be included in a record of a physical quantity? This question is a repeated question and in recent years, they are asking this question again and again. So we need to understand for a physical quantity, all the physical quantities, they have magnitude. So it's very important one. All the physical quantities, they do have magnitude. But all physical quantities, they do not have unit. Mostly we represent a physical quantity with its magnitude and unit. But all the physical quantities, they do not have unit. For example, we have strain. Strain has no unit. Strain is unitless. It has no unit because it's the ratio between two same physical quantities. So it simply means that a physical quantity must have magnitude. Must have magnitude. But unit, most of the quantities, physical quantities, they have units, but some physical quantities, they do not have unit. Question is asking us must. An SI unit? No. An integer value for the quantity? No. A numerical value for the quantity means the magnitude. So it means this one is right. A unit expressed in base units? No. So the answer for this question is C. So this is the point you need to understand. Physical quantity is quantity that can be measured is called a physical quantity. Can be measured is called a physical quantity. Can be measured. So next time they can ask you what is a physical quantity. They can give you some options. Quantities can be measured, quantities cannot be measured, something like that. So you need to understand a physical quantity can be measured. And physical quantities also obey laws of physics. Question 2 says, what is the ohm expressed in SI base units? So simply we need to express ohm into SI base units. And ohm is the unit of resistance and resistance is equal to potential difference divided by I. And potential difference, V means the PD, we can also write down, this is delta V. PD means the potential difference. And potential difference is equal to energy over, or you can say is the work done per unit charge. So let me write down the work done, or you can say the energy transfer. So we can say work done or we can say is energy transfer per unit charge. So we can say work done per unit charge. Work is equal to FD divided by Q, and force we can write down F is equal to MA times T divided by Q. Q is equal to IT. Q is equal to IT because the unit of Q is not SI based unit. So we have to convert this one into SI based units as well. Now simply we can write down for the mass we have kgs, and for acceleration meter per second, and for the distance we have meter, and for I is ampere, and for time is second. Now we can simplify this one and we can write down we have kgs meter square, and we have s to the power of minus 3 and we have a to the power of minus 1. A to the power of minus 1 here. So we can rewrite here. So we have kgs meter square, s to the power of minus 3 and we have a to the power of minus 1, and this is divided by a. So if we simplify this one, we can write down this is kg meter square s to the power of minus 3 and a to the power of minus 2. So this is how you can express ohms in SI base units. So the answer for this question has to be A, because we have kgs, meter square, s to the power of minus 3, a to the power of minus 2. A typical question you will see also in different past papers. So the answer for this one is A. Question 3 says a desk has a true width of 50.0 centimeters. Two students X and Y measure the width of the desk. Student X uses a tape measure and records a width of 49.5 plus minus 0.5 centimeters. So this is the precision of tape measure. So this one is the precision of tape measure. So we can write down this is the precision of tape measure. Student Y uses a meter rule and records a width of 51.4 plus minus 0.1 centimeters. So this is the precision of meter rule. So we can write down precision of meter rule. For this question, we need to find out which statement about the measurement of student X is correct. So if you look at these two precisions, we can simply say precision of Y is higher than precision of X. So we can say precision of Y, this is greater than precision of X. So simply we can write down here precision of X. So it means X is less precise. So we can say X is less precise. So this is one point we can understand from the given data. Now we need to also compare the accuracy. So this is our true value. So 50 is the true value and the answer of X is 49.5. So only 0.5 centimeters difference. So we can write down here difference is only 0.5 centimeters. Now if we compare 50 with 51.4, so here, so in this case the difference is 1.4 centimeters. So it means X is more accurate. So we can say X is more accurate because the answer of this student is close to the true value. It means X is more accurate, but X is less precise because its precision is lower. So more accurate, less precise. If you look at given options, it is given to us it is more accurate, so this is true, but less precise, this is also true, than measurements of student Y. So the answer for this question is D. Precision, it depends on the instrument and also it depends on the number of decimal places, and number of decimal places of course are coming from the instrument. So in this case this is less precise because this instrument is only precise up to 0.5 and this is precise up to 0.1. So X is less precise, but X is more accurate. So precision and accuracy, these are two different terms. Data can be more accurate, but data can be less precise, and vice versa is also true. Question 4 says the diagram shows two vectors X and Y drawn to scale. If X is equal to Y minus Z, which diagram represents the vector Z? So it is given to us that X is equal to Y minus Z, but we need to find out vector Z. So we can write down Z will be equal to Y minus X. We can rewrite this one. We can write down this is Y plus minus X, means the negative vector of X. Negative vector means that magnitude is the same but direction is opposite, so we have to change direction of X. So we can redraw this one in opposite direction. So these two vectors, they have the same magnitude but they have opposite directions. So this vector is minus X, so this one is minus X. So we can say this is our vector minus X now. So this is the negative vector. Now we need to add two vectors. So we can take this vector from here. So first of all, we can take this vector. So this is our minus X now. We can move this one from here and we can add Y and X. So we can place our X here. So the resultant vector in this case, this one will be the resultant. So this is our resultant. So this is resultant. So in this case, we have this is minus x. So this one is c. So the answer for this question has to be A. So this is how you can add vectors together. Question 5 says, which equation representing uniformly accelerated motion in a straight line can be determined using only the definition of acceleration? And acceleration is equal to delta v over delta t, means rate of change of velocity. And change in velocity is equal to v minus u, means the final velocity minus initial velocity over time taken. Delta t in this case will be equal to t if t1 is equal to 0. If we rearrange this one, we can write down v minus u. This will be equal to a times t. So we can say v will be equal to u plus at. So this is how you can derive the first equation of motion. So the answer for this question has to be C. Question 6 says, an object moves from rest with uniform velocity horizontally and uniform acceleration vertically. Which graph showing the variation with time of the displacement of the object from its initial position is correct? So first of all, let's try to visualize the motion of the object. It is given to us object has uniform velocity horizontally and it has uniform acceleration vertically. If uniform acceleration vertically, it means constant force is acting on the object along vertical. So what kind of motion we will expect? So the motion of this object has to be projectile motion. So the force acting on this object along vertical, this force has to be constant. So the acceleration along vertical will be constant. So this is how this object will move, means simply the motion of the object is projectile motion. For horizontal displacement, we can write down x, the horizontal displacement. This will be equal to vh times t. Now, if we sketch the graph between x and t, so you can simply compare this one with y is equal to mx. So if we sketch the graph, it has to be a straight line. So if we take x on y-axis and we take time on x-axis, it must be a straight line because vh is the gradient and gradient has to be constant. Now for vertical motion, initial velocity is 0. Initial, so s will be equal to 1/2 a t square. Now if we sketch graph between s and t, the shape of the graph, this has to be parabola because in this case s is directly proportional to t square. So if we sketch the graph between s and t, it has to be a parabola. So the shape of the graph has to be somewhat like this. So the answer for this question has to be D, because horizontal this is incorrect, horizontal this is incorrect, it has to be a straight line, then this is also incorrect. So the right answer for this one is D. So D is the right answer. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1 variant theory. In today's lesson, our main focus will be on mechanics question and also we will discuss some wave questions. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of mechanics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 7 says, a device for spraying paint consists of a box with its faces horizontal and vertical. One of its vertical faces contains small holes. Paint is fed into the box under pressure via a vertical tube and exits through the holes as fine streams moving horizontally. The paint is ejected at a speed of 2.5 meters per second through 400 holes, each of area 0.4 millimeter squares. The density of the paint is 900 kg per cubic meter. What is the horizontal force required to hold the device stationary as it ejects the paint? So first of all, let's try to understand what is happening in this case. So in this case, paint is coming out of the box. As paint is coming out of the box, it means there is force on the paint, and that force on the paint is from the box. So there is action force on the paint, so there will be reaction force on the box. So action and reaction forces, these are equal in magnitude but opposite in direction. And also we need to understand, in this case momentum of the paint is changing, so it means there is resultant force on the paint. So we can start with F net with resultant force. So we can write down F net. This one will be equal to change in momentum of the paint divided by time taken. So in this case, if you wanna draw the arrow, so in this case paint is coming out, so this is the action force on the paint, and also there will be reaction force on the box, and these two forces are equal in magnitude but opposite in direction. So change in momentum we can write down, this will be delta mv, mean the change in momentum, divided by delta t. In this case speed is constant, so we can take this is speed, this is constant, and here we have this is delta m over delta t. Now delta m over delta t, so how we can calculate delta m? Delta m will be equal to density of the paint times the change in volume of the paint divided by delta t. Now how we can calculate the volume of the paint? Volume of the paint, simply you can imagine in 1 second how much distance is traveled by the paint in 1 second. As we have the speed that is 2.5 meters per second, it means in 1 second the distance traveled by the paint that is equal to 2.5 meters. So simply we can draw one cylinder, so this is cylinder. In 1 second the distance traveled will be equal to 2.5 meters. So this is the length of the paint. So we can imagine each hole like a cylinder, and the paint coming out of that in 1 second is like a cylinder with length 2.5 meters and cross-sectional area is 0.4 millimeter square. Mean this much volume of the paint will come out of the box in 1 second. So we can write on delta V in this case. This will be equal to 2.5 times 0.4 millimeter square. So this is 0.4 millimeter square, mean this is 10 to minus 6, because 1 millimeter, this is equal to 10 to minus 3 meters, and 1 millimeter square, this will be equal to square here. So we will get this is 10 to minus 6 meter square. So we can replace with that. But this is not the total volume. The total volume has to be multiplied by 4, because this is for single hole. So we can say delta V total. This has to be multiplied by 400 times delta V, mean this value. Now we can replace and we can find the answer. So this is the main concept you need to understand. So in this case we have the V speed is given, that is equal to 2.5, and the density is given to us, that is 900, and we have delta V, that is 2.5 times 0.4 times 10 to minus 6 multiplied by 400, because we have 400 holes, and the time taken is 1 second. So this is 1 second. If you solve this one, you will come up with 0.90 Newton. So this much is the force applied on the paint by the box, and the same force will be applied on the box. So to stop this box, we have to apply this much force in the opposite direction of the force on the box. So we have to push this one in direction of paint coming out. So this is how we can balance. So the answer for this question is B. And this question is a repeated question. If you check October-November 2020, paper 1 theory, you can also find this question in that paper. Question 8 says, each diagram illustrates a pair of forces of equal magnitude. Which diagram gives an example of a pair of forces that is described by Newton's third law of motion, mean action and reaction forces? For Newton's third law pair forces, we need to understand few points. Newton's third law pair forces. So few points we need to understand. First of all, two forces must have equal magnitude. Then the second thing, opposite direction. So these are common points, equal magnitude and opposite directions. And also two forces should be of same type. So this is very important one. they must be same type of forces and also acting on two different objects. Acting on two different objects. So acting on two different objects. So this is also very important point. Acting on two different objects. So if you look at these given forces, we will focus on this part because all of these forces, they are equal in magnitude and opposite in direction, so we will not consider first 2 points. Same type. So if you look at option A, this is the driving force and this is the resistive force, so they are not same type of forces. And if you look at part C, they are acting on two different objects, they have equal magnitude and opposite direction, but these two forces, they are not same type of forces. This is the pushing force and this is gravitational force, not same type. Lift is one type of forces and weight is another type of forces, so these are not same type of forces. But if you look at over this system, Earth and Moon system, the force on Earth, this is gravitational force. Force on the moon is also gravitational force. These two forces are acting on two different objects. They have the same magnitude and they have opposite directions, and this fulfill all these characteristics of Newton's third law of pair forces. So the answer for this question is B. A beautiful question, and also this is a repeated question. You can also find this question in other papers. So this is another repeated question. So you need to understand characteristics of Newton third law pair forces. Question 9 says two balls of identical shape and size but different masses are falling through the same liquid. The sum of the drag force and upthrust acting on each ball is equal to its weight. So first of all, we can imagine. This is the best way to answer any question in physics. Imagine means you can sketch the diagram. So we can imagine we have liquid in this container and these two balls are falling in this liquid. So we can draw two balls. We can imagine one ball is here. So this is our one ball and we can draw an other ball here. They have the same size and shape. So they have the same size and they also have the same shape. Now we can say, let's say the mass of this one is m1 and let's say the mass of the second one, mass of this one is m2. So this is mass m1, and in this case m2 is greater than m1 because the mass is not the same. So it means that the weight of 2 w2, this will be greater than w1. Now we need to consider upthrust on these two balls. Upthrust depends on the size of the ball and density of the liquid. Density of the liquid is the same, so it means upthrust in this case is the same on these two balls because they have the same size. Same size means same volume, so we can write on here because they have the same volume, so upthrust on these two balls is the same. And in this case, it is given to us the forces acting on the ball. So first of all, we can draw for red ball. So this is for the red ball. The force acting on red ball in downward direction, this one will be W1. And the force acting in upward direction, this one will be upthrust and there will be drag force. So this one is the Ft. So W1 in this case has to be equal to U plus Ft. But we also need to understand that Ft, drag force, this depend on, this is 6 pi eta RV. You don't need to remember the formula, but you need to simply understand that drag force depends on the speed. So this is the point you need to understand. Now for the second ball, for this blue ball, we can also draw the weight of this one is greater, so this arrow has to be longer, so weight is greater, so this is W2. So in this case, same amount of upthrust, so this is the upthrust, and drag force has to be greater, so this is the drag force, Fd. So in this case, it is very clear. If I say this is 1, this is 2, so I hope you can simply say now that Fd2, this one has to be greater than Fd1. 1. As ft2 is greater, it means that the speed of the second ball, it has to be greater than the speed of the first ball. So this is how you can approach this problem. It means that this ball is falling at higher terminal speed, so we can say this one has higher terminal speed because forces are balanced, so it has higher Vt, and this one has lower Vt. A beautiful way to answer this question. And if you understand this question, a lot of question about fluid you can answer. Almost every year there is a one question based on this concept, so try to master this concept. So what is the answer for this question? The heavier ball has larger acceleration? No, because they are falling at constant speed, forces are balanced, so it means this one is incorrect. Has smaller? No, incorrect. They have zero acceleration because they're falling at constant terminal speed, mean constant speed. Heavier ball is falling at the same speed? No, heavier ball has higher speed. So the answer for this question is T, higher speed, larger speed. A beautiful way to answer. So try to master this. If you understand this question well, it means a lot of question about fluid, about terminal speed you can answer. Question 10 says a perfectly elastic collision occurs between two objects x and y. The mass of x is m and the mass of y is 4m. Object x travels at speed v before the collision and speed 3v by 5 in the opposite direction after the collision. Object y is stationary before the collision. For this question, we need to find out what is the kinetic energy of y after the collision. So first of all, we can label this one as u1. So this is initial velocity of x, and the initial velocity of y, this is u2, and u2 is equal to 0. And velocity of x after collision, this we can label v1, and for y we can label this is v2. This is perfectly elastic collision, so it means that relative speed of approach, this has to be equal to relative speed of separation. This formula is based on all the objects before collision and after collision, they're moving in the same direction. So in this case, we are assuming to the right is positive, and also you have to take to the right is positive and all the objects are moving in the same direction. If the objects are not moving in the same direction, you have to consider sign, means direction you have to consider, as in this case we will do. u1 is moving to the right, so this is positive. u2 is 0, so this is simply 0, so we can write down this one is equal to 0. And v2, this is v2, and we have negative sign here, and this is moving to the left, but we have taken to the right positive, so it means this one is negative 3v by 5. So if we simplify this one, we will get v, this will be equal to v2 plus 3v by 5. Now if we further simplify, we can get v2, this will be equal to v minus 3v by 5. So if we simplify, we will get LCM is 5, so here we will get 5v minus 3v. So the final answer for v, this will be 2v by 5. So this is the value of v2. So we have found value of v2. But for this question, we need to calculate kinetic energy of y. So kinetic energy of y will be equal to the mass of y times the speed of y square. So we have 1/2 and the mass is 4m, and Vy is equal to V2. So this is over Vy after collision. And the value of this one is 2V by 5 square. Now we just need to simplify. So here we have this is 1 by 2, and here we have this is 4, and here we have m. So if you simplify this one, you will get 4v square divided by 25. Now if we simplify this one, we can take, here we have 4 multiplies 16, we will have 16 mv square. 25 times 2 is 50. So this is the kinetic energy. So this is kinetic energy of y. So this is our final answer. You don't need to simplify. If you look at given option, you see the 50. So you no need to divide by 2. So the answer for this question is C, and this is how you can answer. a very good technique when it is perfectly elastically, and simply you can use this formula. And if the objects are moving in the opposite direction, means moving to the left, you can take that speed as negative, mean that velocity as negative, and always you can use this formula, always, for perfectly elastically. And what you need to do is simply you need to change the sign if object is moving to the left. If moving to the right, you have to take positive. Moving to the left, negative, because this formula is based on all the objects are moving to the right, so that's the reason you can use this one in this form. But if object is moving to the left, that velocity you will take as negative. Question 11 says, what is not a requirement for two forces to act as a couple? So first of all, let's try to understand what is a couple. So we can imagine a rod, and we can imagine two forces acting on the rod. One force is acting vertically upwards, so this is force F. Another force is acting on this rod vertically downwards. So they will form a couple if they have the same magnitude. So these two forces, they will form a couple if they have the same magnitude. If they have the same magnitude and they have opposite directions, so we can say these two forces, they will form a couple if they have the same magnitude and they have opposite directions, and there is separation between them, separation between lines of action of forces, lines of action of forces. Means, so this is line of action of this force and this is line of action of this force, so there is separation between them, or simply we can say they are not acting along the same line. If this is true, then this couple will only cause rotation. So the couple will only cause rotation, means the net moment will not be equal to 0. So net moment not equal to 0. But this couple will not cause linear motion. So we will say linear motion. This couple will not cause linear motion. So we can simply cross this one, or we can say no linear motion, because F net in this case is equal to 0. So these are the points you need to understand about couple. So if these conditions are met, these two forces, they will form a couple. So if you look at given options, it is given to us two forces act in opposite directions. This is true. The forces act through the same point. No, they do not act through the same point because they are separated. So they are not acting along the same line of action. This is asking us not a requirement. So it means this one is our answer. The two forces combine to produce zero resultant force. Yes. So this is right. The two forces have equal magnitude. Yes. So the answer for this question is B. Beautiful question. So these are the points you need to understand about torque of a couple, or we can say when two forces they form a couple. Question 12 says a uniform meter rule is pivoted at 34.0 centimeters mark as shown in the figure. The rule balances when a 64 gram mass is hung from the 4.0 centimeters mark. What is the mass of the meter rule? And our answer has to be in grams. So simply for this question, we need to understand first of all forces acting on the meter rule. So in this case, we have weight that is acting at this point, so this is acting vertically downwards, and there is tension in the string that is pulling this meter rule in upward direction. We can say here is tension, and the weight of the meter rule is acting vertically downwards. So the weight of the meter rule, this is equal to mg. We need to find out value of m. So in this case, if we take our pivot at this point, so the moment due to this moment will be counterclockwise, and this one has to be equal to the moment due to the weight of the meter rule, and this moment is clockwise. So simply we can say in this case clockwise moment, this has to be equal to counterclockwise moment, and clockwise moment due to this clockwise moment, this is equal to m times g. This is the g, mass is in grams, multiply by its distance from the pivot, that is 16 centimeters, and this one has to be equal to 64 g. So this has to be 64 g multiply by the distance. So this is 34, this is 4, So it means this is 30.0 centimeters. 30.0 centimeters. Now from here we can cancel this g with this g. Our answer will be in grams because the mass is given in grams. Then this centimeter, this will be cancelled with this centimeter, and our final answer will be in grams. So we have m, that is equal to 64 times 30 divided by 16. So if we solve this one, our final answer in this case has to be equal to 120, because 16, if we divide 64 by 16, we will get 4, and if we multiply, we will get 120. And the mass has to be in grams because the unit we're using for this mass, that is grams. So the answer for this question is 120. So the answer for this question is C. Question 13 says a volume of 1.5 meter cube of water is mixed with 0.5 meter cube of alcohol. The density of water is 1000 kgs per cubic meter and density of alcohol is 800 kgs per cubic meter. Per meter cube you can say, or you can say per cubic meter. The volume of the mixture is 2.0 cubic meters, and what is the density of the mixture? So in this case we need to understand what is conserved, what will remain same, and that is mass of the mixture. Means the mass of the mixture, this one has to be equal to mass of water, means the mass, total mass has to be equal to mass of water plus mass of alcohol. So we can say mass of alcohol. So this is the main thing you need to understand. What is conserved? Mass of alcohol. Mass of mixture we can write down in terms of density and volume, because we need to calculate density of the mixture. We can say density of the mixture times volume of the mixture. So this is a beautiful way how you need to approach. So volume of the water will be equal to the density of water times the volume of the water. So the mass of the water will be equal to this one, volume of water, plus density of alcohol. So I'll be using IL, and times the volume of alcohol. So we need to find the density of the mixture. So we can rearrange, we can write down density of the mixture. This will be equal to density of water, volume of water, plus density of alcohol times volume of alcohol divided by volume of mixture. And so now simply we need to plug in values. So we will just plug in values here. So density of water we have, that is equal to 1000 kgs per cubic meter, and volume of water we have 1.5 meter cube, plus we have density of alcohol, that is 800, times we have its volume, that is 0.5 meter cube, divided by volume of mixture, that is 2.0. Now if we solve this one, we will get density of mixture, that will be equal to 950 kgs per meter cube. So the answer for this question is D. So this is how you can approach questions about mixture. Always you can start with this one, because this quantity is conserved for the mixture. Question 14 says an object is falling at a constant speed through a viscous liquid. F sub u is the upthrust on the object due to the liquid, and WL is the weight of the liquid displaced by the object, and W sub O is the weight of the object. So this is weight of the object. Object is falling at constant speed. We need to find out which equation must be correct. So in this case you need to understand F sub u, this one is the upthrust. So this one is the upthrust, and upthrust has to be equal to the weight of fluid displaced. So it has to be equal to weight of fluid displaced, means weight of liquid displaced. Weight of liquid displaced. And in this case it is given to us that the weight of liquid displaced, this is equal to W times L. W times L, and W sub O means W naught is the weight of the object. So if you look at given options, in this case if you look at option A, it is given to us Fu is equal to WL. It means this option is correct. And upthrust, it is given to us, it is equal to WO minus WL. So this is wrong, because this is the upthrust, and these quantities are the same. So this is incorrect. upthrust is equal to weight of the object? No, because there is also viscous drag. So if we draw the free body diagram, so in this case we have downward force that is equal to weight of the object, then there will be upthrust on this object that is equal to F sub u, and there will be drag force on the object that we can say is Ft. So this is also incorrect because W sub naught is not equal to Fu, and this is also incorrect. So the answer for this one is A. So simply little bit tricky question, so you need to understand the concept in this case. So upthrust is equal to weight of fluid displaced. So the answer for this question is A. Question 15 says an airport has a mechanical system for moving luggage. The system uses a horizontal conveyor belt, a sloping conveyor belt, a lift, and a frictionless slide. A suitcase is moved around the airport using this system. The resistive forces opposing the motion of the suitcase are negligible. For which movement of the suitcase is the net work done on the suitcase greatest? So if you look at given options, for option A, it is given to us moving the suitcase a distance of 8 meters at a constant speed up the sloping conveyor belt here. So in this case, as this one is gaining potential energy, so we can say GPE, as this is gaining potential energy, so the system is gaining potential energy, it means there is net work done on the system. So net work done on the system in this case will be positive, so we can say this is positive. But we have to compare this net work done with this net work done. As in this case, object is gaining potential energy, and gaining potential energy here is much greater than gaining potential energy here. So A cannot be the answer. So A cannot be the possible answer. If you look at option B, it is given to us moving the suitcase a distance of 16 meters at constant speed along the horizontal conveyor belt. So in this case, object is moving at constant speed. Object is not gaining energy, means not gaining potential energy, not gaining kinetic energy. So it means that in this case, net work done on the system, this one is equal to 0 for the second, this part. If you look at option C, it is given to us moving the suitcase a distance of 10 meters at a constant speed vertically upwards on the lift. So in this case, object is gaining potential energy, and gain of potential energy in this case as compared with this one is much greater. So in this case, more work is done on the system. But if you look at option D, in this case, object is losing potential energy. So GPE is decreasing. It means work is done by the object. So we can say in this case, work is done by object. So work is done by object, or we can say work is done by system. So when object lose potential energy, work is done by system. When the object gain potential energy, work is done on system. And in this case, here work is done on system. So here we can also say this GPE is also positive. As here more gain in potential energy, so more work is done on the object. And in this case, there is less gain in potential energy, so less work is done on the object. So the answer for this question has to be C, because we need to find out in which case net work done on the suitcase is the greatest. So the answer for this one is C. D is not answer because moving the suitcase a distance of 12 meters at increasing speed downwards on the slide. So in this case, object is losing GPE. So it means work is done by system. But we need to find out work done on the system. So the answer for this question is C, a little bit tricky one, but you need to understand work done on system. Work done on system. Work done on system increases potential energy. So we can say this increases potential energy, and work done by system decreases potential energy. Question 16 says a car moves along a horizontal road with a constant velocity v against the resistive force capital F. The engine of the car has an efficiency of 25%. What is the input power to the engine? So simply, first of all, we can imagine we have engine. So this one is the engine. P in to the engine means the P input, we can say this is P in, and P out means the output power. This one has to be equal to F times V. So the percentage efficiency, we can simply write down percentage efficiency will be equal to P out divided by P in multiplied by 100. Percentage efficiency, we have percentage efficiency that is 25. P out we have, this is FV, and divided by P in multiplied by 100. For this question we need to calculate P in means the input power. So this will be equal to FV multiplied by 100 divided by 25. So if we solve this one, we will get 4.0 F times V. So this is the input power to the engine. So the answer for this question has to be C. Pretty straightforward question. Question 17 says an object of mass 0.40 kg is projected into the air and follows a curved path above horizontal ground. The object takes a time of 1.5 seconds to move along its path. The object lands a horizontal distance of 18 meters from its initial position. Air resistance is negligible. What is the kinetic energy of the object at its maximum height? So this is just a simple projectile motion. So in this case we have projected object from here. So this is how object is projected. We can resolve this motion into two components. So it has vertical component and it has horizontal component. Horizontal component we can say this is ux. Vertical component we can say this is uy, and the initial speed of this one is u. For this question we need to calculate kinetic energy at this point. So at the maximum height, object has only horizontal component of velocity, mean this is only ux. As there is no air resistance, so it means along horizontal there is no force acting along horizontal, so the horizontal component of velocity will remain constant. And in this case we have the horizontal displacement, so we can say the horizontal displacement simply will be equal to the horizontal velocity component, horizontal component of velocity times time taken. So we have horizontal displacement that is equal to 18. Ux we can calculate from here, and the time taken is 1.5. So we can say Ux in this case will be equal to 18 divided by 1.5. But for this question we need to calculate kinetic energy at this point. So we can say kinetic energy will be equal to 1/2 mux square. So we have 1/2, and the mass of object is 0.40, and the speed we have that is 18 divided by 1.5 square. So if we simplify this one, we will get 29 joules up to 2 SF. So the answer for this question is D. So simply we need to understand at the peak, at maximum height, object has only horizontal velocity, no vertical velocity. A little bit tricky question, but great question to test your conceptual understanding of projectile motion. Question 18 says a metal wire has length 5.2 meters and diameter 1.0 millimeter. The metal has Young's modulus 360 gigapascals. The wire is fixed at one end and a force is applied to the other end. The force extends the wire by 7.2 millimeters. The wire obeys Hooke's law. What is the force applied to the wire? So first of all, let's try to sketch. For this question, it is given to us that one wire is attached to one fixed end. So this is the fixed end. On the other end, a force is applied. So this is the force F, this is applied. We need to find out what is value of this force. So this question is simply about Young's modulus. So we can say Young's modulus, this one is equal to stress over strain. So simply we can write on Young's modulus, this is equal to stress over strain, means the ratio between stress and strain. And stress is F over A, force divided by area. And here we have this is delta L divided by L. So if we rearrange this one, we can simply write down, we will have FL divided by delta L times A, and here we have Young's modulus. For this question we need to calculate F, so we can simply write down F will be equal to Y times A times delta L divided by L. Now simply we need to plug in values. Young's modulus we have, that is equal to 360 giga. Giga means 10 to 9, so this prefix you need to remember. Cross-sectional area, we have diameter, so we can write down cross-sectional area will be equal to pi by 4 d square, and d is given to us, that is 1.0 millimeters, so we have to convert this one into meters. Pi by 4 d square. So this is the diameter. So let me rewrite here. Cross-sectional area is equal to pi by 4 d square, and this is value of d. Delta L, in this case we have force extends the wire by 7.2 mm. So we have value of delta L, so this is 7.2 mm. So this is 10 to minus 3, and this whole is divided by L. L of this wire is given to us, that is 5.2 meters, so we can divide this one by 5.2, and if we solve this one, our answer should be equal to 3.9 times 10 to 2 Newton. So this much is the force applied on this wire. The typical question about Young's modulus, simply you need to understand Young's modulus formula. Young's modulus is the ratio between stress and strain, and then this form you need to understand. This form. Now simply after that you need to plug in values, you need to be careful with units, and you can find the final answer. So the answer for this question is B. Question 19 says the graph shows how the length of a spring varies with the force applied to it. The spring has unstretched length L0. When a force capital F is applied, the spring has length L1. What is the work done in stretching the spring to length L1? So in this case we need to understand work done on spring will increase the EPE of the spring. So we can say work done on spring, this is equal to the change in EPE of the spring. Change in EPE of the spring, and work done in this case will be equal to the average force applied on the spring times the change in length. So the average force, so we have maximum value of force and we have the minimum value of force. So the average will be F maximum plus F minimum divided by 2, because this is changing linearly. So we can say F plus 0 divided by 2, and delta L in this case is L1 minus L0. Now we just need to simplify. So if we simplify this one, we will get this is 1 by 2. We have capital F, and here we have L1 minus L0. So the work done on spring in this case is B. So B is our final answer. So this is how you can also calculate the change in EPE. This is simply equal to this area of triangle. That's all for today's video. I hope this video was helpful. If this video was helpful, please like and subscribe, because your encouragement is very important. And also, if you have any questions, please leave your questions in comments, and I will try to answer as soon as possible. And if you need extra help, please join Patreon, and the link for the Patreon you can find in the description of this video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from June 2023 paper 1. And today's lesson, we will focus on questions from waves. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of waves topic, and also you can have better understanding of these questions. Let's study together, let's improve together. Question 20 says a progressive wave of frequency 1.5 kilohertz travels in a medium at a speed of 340 meters per second. What is the minimum distance between 2 points on the wave that have a phase difference of 70 degrees? So in this case, phase difference is given to us and we need to find the distance between 2 points. In order to find the distance between 2 points, we need to understand the ratio between the phase difference. So we can write on phase difference divided by 360 degrees. This is equal to the path difference divided by the wavelength of the wave. Path difference divided by wavelength. So simply we can say this is wavelength. So this is the main concept you need to understand. So in this case, we need to find out the distance, means we need to find out the path difference between 2 points. So we can rearrange this one. So we can write down in this case path difference. This will be equal to phase difference divided by 360 degrees multiplied by wavelength lambda. So if we have value of lambda, we can figure out path difference, mean we can find the distance between 2 points on the wave. So phase difference in this case is given to us, that is 70 degrees. So this is 70 degrees, so you have to use this one also in degrees. If this is in radian, you can also use this one in radians. So here we have 360 degrees multiplied by wavelength. So we need value of lambda. And so if we have value of lambda, we can simply plug in and we can find the distance between 2 points. So first of all, we need to find out value of lambda. We have frequency of the wave, we have speed of the wave in that medium. So we can say lambda, in this case, this will be equal to v divided by f. So value of v we have, that is 340 meters per second, and frequency is 1.5 kilohertz. So this is 1.5 times 10 to 3. If we solve this one, our answer will be equal to 0.226 meters. So this is value of lambda. Now simply you have to plug in this value here. So we have 0.226 meters. So if we solve this one, our final answer should be 4.4 times 10 to minus 2 meters. So these answers are given in centimeters, so we can simply write down this is equal to 4.4 centimeters. So the answer for this question is A. So the main concept, let me highlight again. This is the main concept. You need to understand the ratio between phase difference and 360 is equal to path difference divided by wavelength. So this is the main concept. Very important concept. Try to remember or try to understand this. Question 21 says graph 1 shows the variation with time of displacement at a fixed distance along a progressive wave. It simply means that if we're looking at one point at a certain distance, we will see how the displacement is changing with time. So this is given in graph 1. Graph 2 represents the same wave and shows the variation with distance of displacement at an instant in time. Mean at certain time we will see with distance how the displacement is changing, and this is given in graph 2. So these are the meaning, so you need to try to imagine that. For this question, simply we need to find the speed of the wave. So from this graph we have time on x-axis, so we can find the time period. So in this case, time period we can write down, time period will be equal to 0.40 seconds. And from this graph we can find out wavelength because we have distance on x-axis. So we can write on here lambda, this is equal to 120 centimeters. We need to find out the speed v. V is equal to f times lambda, so you can write on v is equal to f times lambda, but frequency is equal to 1 over t, so we can say this is 1 over t. So this is the time period, means time taken to complete one cycle, and lambda is the distance traveled by a wave in one time period. So simply we have distance divided by time taken. So we have value of lambda, that is equal to 120 centimeters. We no need to convert into meters because all answers are given in centimeters. Divided by time period, that is equal to 0.40 seconds. Now simply we need to solve this one. This is 0.40 seconds. If we solve, our final answer will be equal to 300 centimeters per second. Quite straightforward question. So the answer for this question is D. What is wavelength? Wavelength is the distance traveled by a wave in one time period. Question 22 says a vehicle moves with constant velocity along a road directly towards an observer. The observed frequency of the sound from the vehicle changes as the vehicle moves past the observer. Which phenomenon explains the change in frequency? This change in frequency is due to relative motion between source and observer. Relative motion between source and observer. And this phenomenon we call is Doppler effect. So this is Doppler effect, the apparent change in frequency. So this is Doppler effect. Doppler effect. So this phenomenon is called Doppler effect. So the answer for this one is simply D. Due to relative motion, the frequency we will hear, that is not the frequency which is produced by the source. So this apparent change in frequency is due to relative motion, and this phenomenon is Doppler effect. Question 23 says an electromagnetic wave has a wavelength of 2.1 centimeters in a vacuum. Which region of the electromagnetic spectrum contains this wave? So the wavelength we have, that is equal to 2.1 centimeters, and if we look at the wavelength of microwaves, lambda of microwaves, that is from 1 millimeter to 30 centimeters, and lambda of radio waves, this is very important to remember this one, and lambda of radio waves is from 30 centimeters to 100 kilometers. So these two ranges are very important. So this is 2.1 centimeters, so it means this is the microwave. So this is microwave. Question 24 says a source of plane polarized light is observed through two polarizing filters. The filters are positioned so that the source appears at its brightest. One of the filters is then rotated clockwise and the other filter is rotated anti-clockwise through the same angle. Means both filters have been rotated through the same angle. How does the source appear when both filters have been rotated 90 degrees and 180 degrees from their initial positions? We have plane polarized light. So we have source of polarized light. Now we need to understand, is it vertically polarized or is it horizontally polarized light? To understand this point, we have to look at these polarizing filters. So we have one polarizing filter here and the other polarizing filter we have here. And in this case, it is the brightest. I mean, just light passes through these filters. It simply means that we have vertically polarized light. So this is vertically polarized light. So this is one thing we can understand about this polarized light. So we have vertically polarized light. Now the second thing we need to understand, it is given to us that one filter is rotated anti-clockwise and one is rotated clockwise. So this filter is rotated anti-clockwise by 90 degrees. So we can again draw this filter here and we can rotate this one by 90 degrees. So by 90 degree, if we rotate, it will appear like this. So this is, it will appear like this. So we have rotated this one 90, so we rotate like this. And the second filter, it is also rotated by 90 degrees, and this is rotated clockwise. So we can rotate this one clockwise by 90 degrees. So this will appear like this. So in this case, you can say this filter is horizontal to this one, angle between them is 90 degrees. So no part of this light will pass through this one. You can also understand this with the help of Males's law, means I transmitted. this one will be equal to I naught cosine square theta. Theta is the angle between polarized light and this transmission axis. If angle is 90 degrees, so if cosine of 90 degrees, square of this one, so it has to be equal to 0. So it means this one will be the darkest. So we can say darkest. No light will pass through these filters. So this is the first case. So answer can be C or answer can be D. A is not possible, B is not possible. C or D, these are two possible options. Now let's look at the second case. For the second case, it is given to us. We rotate this one by 180 degrees. Means we rotate this one like this. So this is rotated by 180 degrees. So you can see here, and this is rotated by 180 degrees clockwise. So first we rotate this one by 90 degrees, then again we rotate this one by 90 degrees. So you can see this is here. So it means in this case light will pass through this because the angle is 0 degrees. So we can also write down here angle between this vertically polarized light and transmission axis 0 degrees. It means cosine of 0 is maximum. So we can write down IT. This one has to be equal to I naught. Intensity of this one we are assuming is I naught. Here we are saying is IT. And this will be equal to cosine of 0 degrees square. So if we solve this one, we will get IT. This is equal to I naught. So it means in this case, this one will be the brightest. So the answer for this question, darkest, brightest. So the answer is C. So this is how you can figure out. So two main problems students they face when they look at this type of problem. First thing, they will ignore that it is given to us plain polarized light. This is one problem student will face. And the second problem is that they will have difficulty to find out, is it vertically polarized, is it horizontally polarized. To find out that one, we need to understand it is given to us. Initially it is the brightest. It means this light is vertically polarized. So if you have understanding of these points, questions about polarizations are not difficult if you have clear understanding of this question. I hope this one is clear to you, and if you have any questions, please leave your questions in comments and I will try to answer as soon as possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from May June 2023 paper 1. In today's lesson, our main focus will be on waves, electricity and radioactivity. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of these topics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 25 says the diagram shows a string stretched between fixed points x and y. There is a stationary wave on the string. The solid curve shows the string at a position of maximum displacement at time t naught. The dash curve shows the other position of maximum displacement. The straight centered dashed line shows the mean position of the string. Point S on the string is directly above point P and point D on the string is directly below point Q. Which statement is correct? So first of all, let's try to understand a little bit about stationary wave. If you look at motion of this particle will go down. So this is one thing we need to understand. This particle will go down and all the particle here, this particle will also go down, particle here, this will also go down. And particle at this point, this particle will move up. And all the particle between these two nodes, they will be moving up. So they will be moving up. So all the particles will be moving up. So these are some points we need to understand about stationary waves. We can also look at this part. In this loop, mean between this node and this node, all the particles, they will be moving down. In particle here, this will be moving down. Particle here, this also will be moving down. So the particles in two consecutive loops, they move in opposite directions. Mean particles between these two nodes and particles between these two nodes, this is one loop. These particles, they will move in opposite direction to particles here, and also they will move in opposite direction to particles here. So this is very important point you need to understand. Now if you look at given options, it is given to us a short time after t0, point r on the string will be displaced. This point, this is the node actually. Particles at node, they just stay at node because they have zero displacement. So it means this option is incorrect. A short time after t0, points s and t on the string move in opposite direction. This one is correct. So we have point S, this point is moving down, this particle is moving down, and particle at point T, this will be moving up. So they are moving in opposite direction. So it means option B is correct. The distance between P and Q is one wavelength. Means distance between this point and this point is one wavelength. This is incorrect because this distance, this is equal to lambda by 2, because this is the distance between two consecutive antinodes. So this is also incorrect. The two moving points on the string that are equal distance from point R vibrate in phase. So we have point R here, so we can consider one point here, and we can consider one point here. These points will be moving in opposite direction, not in same direction. So it means not in phase. So this option is also incorrect. So the answer for this question is B. So this question covers some important points about stationary waves. So these points are important, you need to understand. Question 26 says the variation with distance x of the intensity I along a stationary sound wave in air is shown in the figure. The speed of sound in air is 340 meters per second. We need to find out what is the frequency of the sound wave. So we have speed, we need to find the frequency. So if we have value of lambda, we can find out frequency. So for this one, it is given to you, this is a stationary wave. So it means this point has maximum intensity. So this point is antinode and this point is node. You can mark this point. So this one is antinode and this one is node. And the distance between two consecutive nodes are antinodes. This distance is equal to lambda by 2. Mean the distance between any two consecutive nodes or antinodes is equal to lambda by 2. So it means this distance is equal to lambda by 2. So we can write down here lambda by 2 in this case is equal to 10.0 centimeters. So lambda will be equal to 2 times 10.0 centimeters. It means this is equal to 20.0 centimeters. We need to find out frequency. Frequency will be equal to V divided by lambda, and value of V is given to us, that is equal to 340 meters per second. So lambda we also need to convert into meters. So simply we can write down this is equal to 0.20 meters. Now if we simplify this one, we will get 1700 hertz up to 2SF. So this is our final answer. This is how you can figure out. Now let's try to visualize how the stationary wave will look like. If you draw the stationary wave, it should look like this. So you can see, you can also redraw. So in this case, you can see this point is node, this point is also node, and here we have antinode. So this point is antinode. So you can also draw the stationary wave here, so you can see the clear picture of stationary wave. Question 27 says an experiment is set up to demonstrate the diffraction of water waves in a ripple tank. The waves pass through a gap of width W and some diffraction of the waves is observed. The wavelength of the waves is now doubled. What is the new gap width needed to cause the same amount of diffraction as before? So for this one, we need to understand, imagine that these are the waves, they are coming, and here we have a hole, means we have a slit here. If we increase this wavelength, if we increase lambda, diffraction will increase. So if we increase lambda, diffraction will increase. Diffraction will increase. And if we make this hole smaller, if we make hole, we can say the width, if we decrease the width, diffraction will also increase. Diffraction also will increase. And if we increase the width, if we increase this width, mean this gap, diffraction will decrease. Diffraction will decrease. But for this question, we have increased this lambda 2 times. So it means diffraction will increase by 2 times. To keep the same amount of diffraction, we also need to increase the width. So diffraction will decrease. So we also need to multiply this one by 2. So the new width has to be equal to 2W, because this will decrease the diffraction. It will bring diffraction to the same amount as before increasing the wavelength. So the answer for this question has to be C. So this is the important point. Means if we increase wavelength, diffraction increases, and vice versa is also true. And if we decrease the width, diffraction increases, and if we increase the width, diffraction decreases. So the answer for this question has to be C. Question 28 says two coherent electromagnetic waves are traveling in a vacuum. The two waves meet at a point. At this point, the two waves have different intensities. Which statement about the waves is not correct? So these are coherent waves. So we need to understand the properties of coherent waves. Two waves are coherent if they have constant phase difference. So this is the first condition, constant phase difference. Constant phase difference. And that is only possible if waves they have the same frequency. We can also say they should have same frequency. So we can write down same frequency. And also we need to understand these are two electromagnetic waves. So they are same type of waves. So they have the same speed in the same medium. So they have also the same speed. Same type of waves, they have the same speed in the same medium. So we can say same speed. So they also have the same speed. Because speed of the wave, it depends on type of the wave and medium. So they have the same speed. Now if you look at given options, it is given to us constant phase difference. This is right. They have the same frequency. This is right. They travel at the same speed. Yes. They have the same amplitude. This is incorrect. So this one is the answer. This is incorrect because intensity is directly proportional to amplitude square. If intensity is different, it means amplitude has to be different. So the answer for this question is B. Question 29 says a parallel beam of light of wavelength 600 nanometers is incident normally on a diffraction grating. The distance between the adjacent slits in the grating is 2.0 times 10 to minus 6 meters. A screen is placed parallel to the grating at a distance of 1.50 meters from the grating. Third order diffraction maxima are observed at the two ends of the screen as shown in the figure. We need to find out what is the distance between the two ends of the screen. Means we need to figure out this distance. So simply we can say this total distance, let me draw a dotted line here. Let's say this total distance, this is equal to capital H, and this distance, half of that, this distance, we can label this one is H. So you can see this is just a triangle. So this one is the triangle. So first of all, we will try to find out this angle. And this question is about diffraction grating. So for diffraction grating, d sine of theta, this is equal to n times lambda. So we can find out value of angle. D is given to us. So this one is the d we have value of lambda, and we also have value of n. So we can rearrange this one. We can write on theta in this case. This one has to be equal to sine inverse of n lambda by d. N lambda by d. Now we can plug in values. we have in this case n, that is 3, and lambda is given to us in nanometers, so we have to convert this one into meters, and we need to divide by d. D is the distance between two adjacent slits, and this distance is 2.0 times 10 to minus 6. Now if we solve this one, in this case we will get value of theta, means we will be able to find this angle, and this angle will be equal to 64.2 degrees. So now we have value of this angle. We can find out value of h, because we have this side, this is equal to 1.50 meters, and value of angle we have found, that is equal to 64.2 degrees. We need to find out h, so simply we can write down tangent of theta, in this case will be equal to h divided by 1.50. So h in this case will be equal to 1.50 times tangent of angle, tangent of this angle, that is 64.2 degrees. If we solve this one, we will get 3.1 meters. So this is value of small h, but we need to find out capital H, that is equal to 2 times of h. So it means 2 times 3.1, so we will get 6.2 up to 2 SF. So the answer for this question has to be D. A nice question. This is how you can approach diffraction grating problems. Question 30 says a metal wire is connected between the terminals of a cell, so there is a current in the wire. Which statement is correct? So first of all, we can simply imagine we have a cell and a wire is connected between the terminals of this cell. So we can imagine this red is the wire. So this is the wire. So in this case, electrons will flow from the negative terminal of the battery. So they will flow in this direction and they will come to the positive terminal of the battery, because only electrons flow. So if you look at given options, we have negatively charged electrons in the wire move from the negative terminal to the positive terminal. So this statement is correct. Negatively charged nuclei, this is incorrect. Positively charged electrons, incorrect. Electrons are not positively charged. Positively charged nuclei, so these options are incorrect. So simply you need to understand only electrons flow. So the answer for this question has to be A. Question 31 says two resistors of resistance R and 2R are connected in parallel with a battery of electromotive force 12 volts and negligible internal resistance. The total power dissipated by the two resistors is 36 watts. We need to find out what is value of capital R. So in this case, these two resistors are connected in parallel, so we can find out R total. First of all, R total. This will be equal to R times 2R divided by the sum of these two. So this is the sum of these two. So here we will get 2R square, and this is divided by 3R. So we can cancel this R with this. So we left behind 2R divided by 3R. Simply we can say it is equal to 0.6R. So this is the total resistance. This is the total resistance, and we need to find out the value of R, but power is given to us. So simply we can say power, this will be equal to V square divided by R total. Value of V we have, that is equal to 12 square, and value of R we have, value of total resistance we have, that is equal to 0.6 R, and the power we have, that is equal to 36. So for this question, simply we need to find out value of R, so we can rewrite this 0.6 R. So we need to find out value of R. So if we rearrange this one, we can say 0.6 R, this will be equal to 12 square divided by 36. We need to find out R, so we can divide both sides. So this is 12 square divided by 36 multiplied by 1 over 0.6. So if we solve this one, our final answer will be equal to 6.0 ohms. So this is the final answer, and this is how you can approach this problem. Quite straightforward one. Question 32 says a wire has a length of 3.0 meters and is made of metal of resistivity 4.9 times 10 to minus 7 ohms meter. A potential difference of 12 volts is applied across the wire so that it has a current of 1.4 amps. What is the cross-sectional area of the wire? So first of all, we can draw the circuit. So here we have the power supply and we have a wire. So we can imagine we have wire here. So this is the wire. So we can little bit draw in a better way. So we have the wire, so we can imagine this one is over wire. So we can make this one a bit thicker so you can see the difference. So this one is the wire. So it's very important in physics to sketch the diagram. Diagram is very important in physics. So you have to make this one your habit so you can improve yourself step by step. So this is the wire we have. The length of this wire is given, resistivity is given, current passing through this wire we have, and the PD across this wire also we have. If we connect voltmeter across this one, reading on this voltmeter will be equal to 12 volts, and current passing through this wire is 1.4 amps. So these informations are given to us. We can say this is 12 volts battery. We need to find out value of cross-sectional area of this. So simply, first of all, we can find out value of resistance. So the resistance of this wire will be equal to V divided by I. Means this will be equal to 12 divided by 1.4. So this is value of resistance. We need to find out cross-sectional area. So we need to understand resistance is equal to rho L by A, and this is equal to 12 divided by 1.4. So we can rearrange this one. We can write down 12A. This one will be equal to 1.4 times rho times L. And if we divide this one by 12, so it means we can find out value of A. So this is our value of A. Now simply we need to plug in values and we can find out value of A. For this one, it is given to us that resistivity, this is equal to 4.9 times 10 to minus 7, and value of L we have, that is equal to 3.0 meters divided by 12. If we solve this one, our final answer should be equal to 1.7 times 10 to minus 7 meters square. So the answer for this question is B. Question says a cell of negligible internal resistance is connected in series with a thermistor, a fixed resistor, and an ammeter. The thermistor is placed in a beaker of water and the temperature of the water is slowly increased. A graph of current against the temperature T of the thermistor is plotted. Which graph could show the variation of I with T? So first of all, we need to understand for the thermistor, if the temperature of the thermistor increase, resistance of thermistor decreases. If the temperature increase, resistance of thermistor decreases. It follows this curve. So for this question, it is given to us that temperature is increased. So if temperature of thermistor is increased, it means resistance of thermistor, this one will decrease. So resistance of thermistor will decrease. We can also sketch the circuit. So here we have cell and we have a thermistor. So it is given to us a thermistor is connected, and we have a fixed resistor that is connected here, and it is also given to us an ammeter is connected in series. So if you look at this given setup, as temperature is increasing, resistance of this thermistor, resistance will decrease. As resistance of thermistor decrease, it means the total resistance in the circuit decrease. If the total resistance of the circuit decrease and EMF of power supply remains constant, so it means current in the circuit will increase. So current passing through thermistor will also increase. So as temperature increase, current has to increase. So it means this is not possible. So this is our possible answer. This is not possible. This is telling you decreasing. This is also telling you is decreasing. Question 34 says a battery with internal resistance is connected to a parallel arrangement of two resistors and a switch S as shown in the figure. Initially, switch S is open, what happens to the voltmeter and ammeter readings when switch S is closed? So first of all, we need to understand when we close this switch, what will happen to the resistance of this part. So the total resistance of this part, we can say R parallel, this resistance will go down. As this resistance go down, it means the total resistance of the circuit, this will also go down. So we can say R total of the circuit, this will also go down. If total resistance of the circuit decreases, it means current in the circuit, means I total, this one will increase. But for this question, we need to understand this voltmeter is telling us terminal PD, means VT. Terminal PD. So the potential difference between this point and this point is the same as potential difference between these 2 points here. So if we connect our voltmeter here, reading on this voltmeter and reading on this voltmeter has to be the same. So this is terminal PD. So in this case, we can write down EMF. This one will be equal to the terminal PD plus V lost. So here we have V lost. So we can write down in this case terminal PD, this will be equal to EMF minus I times R. So now simply we need to understand this one is constant, this quantity is constant, this quantity is constant. So if I increase, how about this overall? This one has to decrease. It means terminal PD, this will decrease, but current will increase. So this one will decrease and total current in the circuit will increase. So ammeter reading will increase and this reading of voltmeter, this will decrease. So voltmeter reading decreases, ammeter reading increases. So the answer is A. So this is how you can figure out a typical question. You will see this one in many past papers. So this is the main concept. You need to understand how to use this equation. Question 35 says Kirchhoff's first law states that the sum of the currents entering a junction in a circuit is equal to the sum of the currents leaving the junction. The law is based on the conservation of a physical quantity. What is this physical quantity? Kirchhoff's first law simply tells us that sum of currents entering a junction, so we can say entering a junction, this is equal to sum of currents leaving the same junction. Leaving. We can also write down this one. This means the sum of the charge, or simply we can say the total charge entering the junction. So we can write down Q total entering the junction in a given time, let's say in time delta t. This one has to be equal to Q total leaving the same junction over delta t. So in this case, we are talking about the same amount of time. So it means same amount of charge has to enter and same amount of charge has to leave the junction. So this law is simply based on conservation of charge. So we are simply talking about conservation of charge. So this is entering Q total, entering, so this has to be equal to Q total leaving. So this is based on conservation of charge. So we can say this is based on conservation of charge. Conservation. Question says two resistors have a combined resistance of 34 ohms when connected in series. The same resistors have a combined resistance of 7.4 ohms when connected in parallel. What is the resistance of one of the resistors? So we can sketch first of all. It is given to us when two resistors, they are connected in series. The total resistance of these two resistors, this is equal to 34 ohms. Means R1 plus R2, this is equal to 34 ohms. From here we can also write down that R1, this will be equal to 34 minus R2. So we can say this is equation 1. Later we will need this one. And for the second setup, we have two resistors. They are connected in parallel. So we can draw this one, mean two resistors are connected in parallel. So this is our R1, this is R2. Order doesn't matter. and the total resistance of these two is equal to 7.4. So we can write on this will be equal to the product of these two resistors divided by the sum of these two resistance. We can say this is our second equation. Now we can substitute R1 is equal to 34 minus R2 in second equation. So simply we can plug in here now. So we have 7.4, this is equal to 34 minus R2 times we have R2, and this is divided by 34 minus R2 plus R2. Now we just need to simplify. We have discussed the physics. This is the math part. We just need to simplify. So we can cancel this with this one. So we can cross multiply now. So we will have 7.4. This will be multiplied with 34. And here we will have 34 times R2 minus we will have R2 square. So we can multiply both sides. We can rearrange first of all. We can write on this is minus R square. We have plus 34. So this is 34. So we have 34 R2 minus we will have 7.4 multiplied by 34. So here we have 34. This one has to be equal to 0. So we can multiply with minus sign. So we will have R square minus 34 R2, and we will have plus here 7.4 times 34, and this is equal to 0. We need to use the quadratic formula. So here we have A, that is equal to 1. We have B, that is equal to minus 34, and we have C, that is equal to 7.4 times 34. Now simply we can write on here R2 in this case will be equal to minus B plus minus B squared minus 4 AC. This is just quadratic formula divided by 2A. So here is our R. Now we need to plug in values and we can find the value of R2. We have value of B, that is minus 34. We have plus minus B is minus 34 square. We have minus 4. We have value of A, that is 1. We have value of C, that is 7.4 multiplied by 34, the root of this one, and this is divided by 2 times A. Now if we simplify this one, we will get two values of R. One value will be 23 and one value will be 11. If you look at given options, we don't have 11. So the answer for this question has to be C. So C is the answer. You can just simplify. You will come up with these two values. So in this case, this is not given. So we will choose this one. So this is value of R2. Question 37 says a potentiometer circuit is used to investigate the electromotive force of a cell X. The EMF of cell X is approximately 0.50 volts. The driver cell has negligible internal resistance. It's very important point. You need to check this driver cell, it has internal resistance or not. And EMF of driver cell is given, that is equal to 2.0 volts. The sliding contact is moved along the uniform resistance wire between ends Q and R to a point P where the reading on galvanometer is 0. What is an expression for the approximate length QP? Means we need to find out this length QP. Now for this question, it is given to us the reading on galvanometer is equal to 0 when the sliding contact is at this point. It means that the potential difference between Q and P, this is equal to the EMF of this cell, and EMF of this cell is 0.50. So we can write on here the reading on voltmeter will be 0.50 volts, and the potential difference between point Q and R, this is equal to the EMF of driver cell, because driver cell has no internal resistance. If driver cell has internal resistance, then we need to take the terminal potential difference across the terminals of the driver cell. Terminal potential difference then we need to take. So in this case, we have VQR, that is equal to 2.0 volts. And also we have in this case VQP, that is equal to 0.50 volts. We are talking about the same wire. For same wire, this is the point you need to understand. For same wire, current is the same. Means the same current is passing through this part of the wire and same current is passing through the remaining part of the wire, because current through galvanometer is equal to 0. So simply then we can say IQP, this is equal to IQR. So this is the main concept you need. So also, before I answer this question, you need to understand internal resistance of test cell. It doesn't matter. It has internal resistance or it has no internal resistance, because when current is 0, it means voltage lost across internal resistance, that will be equal to 0. So internal resistance of this cell doesn't matter. It has internal resistance or it has no internal resistance. But internal resistance of driver cell, it matters. Then if driver cell, it has internal resistance, so you have to take the terminal potential difference across driver cell. So that's the very important point. Or simply I can say what you need to take, V is this value of V. This has to be the PD across the wire. So that's the reason I have written here VQR. That in this case VQR, this is equal to EMF. So you have to take VQR. So IQP we can calculate potential difference, that is 0.50 across this part of the wire divided by the resistance. So resistance will be equal to rho L. So this L will be LQP divided by A. So here we will have 2.0 and this will be divided by the resistance. So the resistivity times length, Q times R divided by A. So this is uniform wire, so it means cross-sectional area is the same. We are talking about the same wire, so resistivity also is the same, so resistivity will be cancelled. So we left with 0.50. This is divided by LQP and this is equal to 2.0 divided by LQ times R. And for this question we need to find out value of QP. So value of QP we have to find out. So we need to find out LQP. So we can write down in this case LQP. This will be equal to 0.50 times LQR divided by, so this will be divided by 2.0. Divided by 2.0. So it simply means that what we will get LQR divided by 4, because this is 0.5 and this is 2, so we will get 4 here. So our final answer in this case is LQP, means QP, this is equal to LQR divided by 4. So the answer for this question is A. So the answer for this one is A. The quick way to answer this question is, for example, if I look at this now, this is lower than this one by 4. I mean, this is 1 by 4. So here also has to be 1 by 4. I mean, this has to be 1 by 4 of this length. So quickly you can answer with this technique if you master this kind of questions. I hope this is clear to you. If you have any questions, please leave your questions in comments. In this question, I have discussed some very important points and you need to understand those points for potentiometer. Question 38 says the table contains data for 4 different nuclei P, Q, R and S. Which 2 nuclei are isotopes of the same element? Isotopes of the same element, they must have same number of protons. Same number of protons. So here we have nucleon number and here we have number of neutrons. So the proton number, or simply we can say the number of protons. Number of protons will be equal to the nucleon number. Nucleon number is the sum of neutrons and protons minus neutron number. So we can simply say minus neutron number, because nucleon number is the sum of neutrons and protons. So from here we can find out number of protons 5, and for Q we can find out number of protons, they will be equal to 4, and for the next one we can find out number of protons, they will be equal to 8, and for the next one number of protons also equal to 8. And so it simply means that R and S, they are isotopes of same element, R and S. So the answer for this question is D. Question 39 says, which statement about beta minus decay is correct? So first of all, let's try to understand a little bit about beta minus decay. So we can imagine a nucleus X, atomic number of this nucleus is Z, and the mass number is A. So this decays to another nucleus Y by emitting beta minus particle, mean electron. As electron has lepton number 1, so this particle means the neutrino has to be electron anti-neutrino, because lepton number of anti-neutrino is electron anti-neutrino is -1, so in this case lepton number will be conserved. So that's the reason this has to be electron anti-neutrino to conserve lepton number. Now if you look at this nucleus, atomic number of this one will be Z plus 1, because this is -1, and mass number remains constant. So in this case proton number increases but mass number remains constant. It simply means that one neutron is converted into proton. So we can also say in this case we have quark composition of neutron. It consists of one up quark and it consists of two down quark. It decays into proton. Proton has two up quarks and one down quark. So we can also say in this case one down quark has been converted into up quark. Now if you look at given options, it is given to us a neutron changes to a proton in the nucleus, and an electron and an anti-neutrino are emitted. So this statement is correct. A neutron changes to a proton in the nucleus, this is right. Electron and neutrino, this is incorrect. A proton changes to a neutron, this is incorrect. A proton changes to a neutron, this is also incorrect. In this case neutron changes to proton. So the answer for this question is A. Question 40 says, what is the quark composition of a hydrogen 3 nucleus? So this is over nucleus. This nucleus, it consists of one proton. So simply we can write down it consists of one proton and it consists of two neutrons. So we can write down here it consists of two neutrons. One proton, it has two up quarks and it has one down quark. So it has two up quarks and it has one down quark. And one neutron, it consists of one up quark and two down quarks. So we need to write down the total number of up quarks and total number of down quarks. So here we have one down quark plus we have two up quarks, plus we have to add this one. So we have in this case two up quarks plus we have 2 times 2 down quarks. So if we simplify this one, we will have 4 up quarks. So we have 2 up quarks here and we have 2 up quarks here, so it means 4 up quarks, and we have in this case 5 down quarks. So the answer for this question is A, means 4 up quarks and 5 down quarks. That's all for today's lesson. I hope this lesson was helpful. If this lesson was helpful, please like and subscribe, because your encouragement is very important. If you have any questions, please leave your questions in comments and I will try to answer as soon as possible. Then also, if you need extra help and you are looking for extra resources, join Patreon, and the link for Patreon is in the description of this video.